So then let's look at a couple of examples here. Now, notice I have values up here. This will always be given to you at the top or in a table on your test, okay? These are your constant values. So these are your C values. So these are equal to C for the substance that we're looking for. So this is the specific heat of water, and this is the specific heat of copper, okay? So now you have to look at the equation. So you have to look at what's happening in the reaction or in the process that you're looking at. It says what mass of water can be heated from 25 degrees Celsius to 50 degrees Celsius by the addition of 2,925 joules of energy. Now, one of the first things that we need to look at is it exothermic or is it endothermic? Looking at this, and I'm wanting to figure out, is this exo or endothermic? Is this an exothermic or an endothermic process? I'm going to look and see, oh, it's adding. So I'm addition. So if I'm adding heat to the water, then that has to be endothermic. Okay. So then I'm looking for, so what I'm given my energy. This is my Q, right? And I'm given my change in temperature. So from here to here, it's about 25.0 degrees Celsius, and that's equal to my delta T. Right, so I'm given Q, I'm given delta T, and up here, this is my value for C. So that's C for water, because I'm looking at water. So I'm looking at my substance of water. So now I'm looking for my mass. So my mass is equal to my Q divided by my cat. Okay, so then I'm going to have 2925 joules over 4.184 joules per gram degrees Celsius. And then, so the other thing that is down here is 25.0 degrees Celsius. So my degrees Celsius cancels, my joules are canceling. I'm left in this gram unit here. Okay, and then I can calculate. So calculating this out, I get 2925 divided by 4.184. Now, because this is on the bottom again, I have to hit divide again, okay? Divided by 25.0. And that gives me 27.96367113. Now, I need to look for my sig figs here. So I've got 3 sig figs here, and I've got 4 sig figs here. So I need 3 sig figs in my answer. So that's going to give me 1, 2, 3. The 9 is going to raise to a 0. The 7 is going to raise to an 8. So 28.0. So this is 28.0 grams of water. And that is my answer for that particular problem. So for number 2, I've got a couple of different things here. So I've been given my mass. I know it's water, so I'm going to use that 4.184 unit again, 4.184. And then this is a temperature measurement. So it's asking me for the final temperature. This is my temperature initial then. Okay, so that's my initial temperature. I'm losing. So this means this is exo. Okay, so then that means that this guy right here is actually negative. Okay, so then I'm looking for my final temperature actual is equal to Q over my mic, right? So now my Q has to be negative here because I'm losing, so I'm exothermic, so I'm losing heat here. So minus 796 times 10 to the 4 joules over my mass, which is 625 grams. And then also I've got 4.184, and I've got joules per gram degrees Celsius here. So then my grams are canceling, my joules are canceling, and I'm in my degree C. So then this is equal to my change in temperature, which is so negative 7.96 second e to the 4 divided by 625 divided by 4.184. That gives me negative 30.4. So I'm going to look here to see like what my numbers are here. I've got 3 sig figs here, 3 sig figs here, so I just need 3 numbers here. So then my change in temperature is negative 30 degrees Celsius. So negative 30.4 is equal to my T final. And then I've got negative, and then this number right here is 75.0. So then I take the negative 30 and I add 75 to that. So then 30.4 minus 75, or plus 75, my bad. And that gives me 44.6. So my final temperature is 44.6 degrees Celsius. My second question, and it's 2 parts. So I have to solve for this part first, which is my change in temperature. This is my delta T. And then I set that equal to my T final minus my T initial. I plug in my T initial, and then I can solve for my final temperature. The last one is I've got a couple of different things here. So I've got copper. There's my copper. And I've got a mass of 76.8. And this is heated to 86.5 degrees Celsius. So this is all copper. And then I also have 68.7 grams of turpentine. So this is a different substance, right? And this is my initial temperature of 19.5. So the copper cylinder is placed into the turpentine, and my final temperature for both of these things is 31.9. So this is my T final for both, okay? And it's asking me, what is my specific heat of the turpentine? So I'm looking at the turpentine. What is my specific heat value for the turpentine? So I've got 1, 2, 3, right? So this is my mass, my temperature initial, my temperature final. And I also have my specific heat value that's up here. So 0.092 calories per gram degrees Celsius. So I'm going to write this over here. 0.092 calories per gram degrees Celsius. This is the specific heat value for copper. So that's C for copper. Okay. Now, one thing that I should know about this is that I have what's going on here is I have the law of conservation of energy here. So now the Q, because copper is going to be losing, so the Q from the copper is equal to the positive Q for the turpentine. Okay. So then I have everything for copper, and the only thing that I do not have for turpentine is the C value. So I can set all this up. So I've got negative because I'm losing heat for copper. So negative 76.8. And I'm going to multiply that by the 0.092. And then I'm also going to multiply that by my change in temperature. So my T final is 31.9 minus 86.5. And this is all equal to my mass of my turpentine, which is 68.7, times my C value, which is what I'm looking for. So this is my X value, right? And then I'm going to have 31.9 minus 19.5. Because this is my temperature initial for my turpentine and my temperature final for my turpentine. So then I have all this, and then I need to solve for C. So here and through all of this, right, I'm going to divide by 68.7 times 31.9 minus 19.5. So whatever I do to one side of the equation, I have to do to the other side of the equation. Okay, Now, this is canceling, this is canceling. I'm left with my x value on this side. So then all I have to do is solve all of that. So then plugging this into the equation, so I've got negative 76.8 times 0.092 times 31.9 minus 86.5, close parentheses, divided by 68.7, divided by parentheses 31.9 minus 19.5, close parentheses, and then I hit equals. So then this is going to equal to 45.45. And I've got 3 sig figs, 3 sig figs, 3 sig figs, 3 sig figs, 3 sig figs. So I'm going to put my answer into 3 sig 0.453. Now I'm going to look at this unit here because this unit here is going to give me my actual unit for my C value. And this is going to be calories per gram degrees Celsius. And that is how you do a calorimetry problem.